For the last couple of weeks, I've been working in Blender 4.2 to find new ways to implement matrix nodes. And at some point I got to this very cool flower blooming effect, which I just had to turn into a tutorial. So let's get started. For this tutorial I actually pre-created this leaf so that we don't have to do the 3D modeling part and we can dive straight into geometry nodes. However, if you want to use your own leaf for this tutorial, you could do that, but make sure that the origin point of your leaf is at the bottom of the leaf. And also to make it easier, make sure that it's like laying flat and also aligned on the y-axis like this. That way you should be able to follow this tutorial with your own custom leaves. So with that being said, let's go into geometry nodes, and in geometry nodes we're going to click on new to create a new geometry nodes for this leaf. And the first thing that we want to do is make this leaf bend or bloom, so to say. So basically we want that it goes from this position to this position, and that we're already going to do with matrix nodes. So in order to apply a matrix transformation onto this mesh, we are going to need a set position node and also a position node. And if we connect that like this, now we're basically saying, okay, the new position stays the same as the old position. However, we want to modify this old position with matrix nodes. So we need to do a transform point node, which we connect like this. And now we can apply a matrix transformation on this position. And this matrix transformation, we're going to create that from a combine transform node. And if you connect that like this, then you will see we have this rotation socket. And if we rotate this over the x-axis, you see we're kind of already blooming the leaf. However, it's going in a very linear way. What we kind of want is that the parts that are over here will bloom or rotate over the x-axis more than the parts that are over here. So we want the x-axis rotation to be dependent on the y location. So what we're going to do is a combine XYZ node so that we have control over the separate X, Y, and Z sockets. And then to get the Y location of each point, we want to do a position node so that we have the original position. And to extract the Y axis from this, we do a separate XYZ, and then we connect the Y axis with the X axis like this. And then you see we're already getting a blooming leaf, as you can see. However, we want to modify this so that we have control over how much the leaf is going to be blooming. And this we're going to do with a map range node. So if we do map range node, now you will see, okay, the map range thinks that this y-axis goes from 0 to 1. However, it doesn't. This is not from 0 to 1. And to actually get the right value for this minimum and maximum value, we want to do an attribute statistic node so that we get like mean, medium, sum, min, max. We want to get the minimum and maximum from this Y location, and the geometry from which we want to extract that is the original geometry. So if we put the group input like this, now we have the minimum and maximum of this thing. And now if you're changing the to min value, you see that you're more moving the points that are closer to 0 over here. And if you change the to max value, then you see you're kind of blooming the leaf, which is perfect. So for now, we're going to leave it like this. Later, we're going to add a little bit more to this. The next thing that I want to do is adding in more leaves. So let's make some space like so and like so. And we are going to add more leaves with a repeat zone. And basically what we want to do is the number of iterations is going to represent the number of leaves that we're adding in. So to add a new leaf each iteration of the repeat zone, we want to do a join geometry over here. And then if we connect the group input right over there and we do Alt Shift click on the repeat zone, then we see, okay, at the moment it looks like it's still one leaf. However, there are actually already 4 leaves. And an easy way to see that there are more leaves is to actually move each leaf a little bit up with a transform geometry node. So if you put the transform geometry nodes right over here and you put the z-axis on like 0.005, for example, then you will see that there are actually 4 layers of leaf. And now it comes the cool part, because if we now put the repeat zone into the set position and the set position with the group output, then you'll see it will just bend those 4 leaves in a good way. However, what we want to do now is actually rotating each leaf along the z-axis so that it will actually look like a flower, right? Because at the moment it's not really like a flower. So what we want to do is adding in a second matrix transformation onto this mesh. And you can add another matrix transformation with a multiply matrices node. And this second transformation, the rotating transformation, we are also going to get that from a combine transform node. However, that rotating around the z-axis actually needs to happen before the blooming part. Otherwise, it's not going to work. So what we need to do is having the blooming part as the second socket of the multiply matrices and the rotating part as the first socket, so that it goes in the right order. So in this combine transform node, we of course want to manipulate the z-axis, as you can see. So let's do a combine XYZ again. And then for the z-axis, we kind of wanted that each leaf gets an offset, but not really random, but that it's like shifted like a deck of cards, so to say. And the easiest way to do this is to first go back to the repeat zone, because in order to do that, we first need to assign a number to each leaf, or an ID, so to say. So what we want to do is a set ID node, and as the ID, we want to have the iteration that the leaf got added in. So if it got added in at iteration 4, it will have an ID of 4. So in order to do this, let's actually connect this empty socket with the ID of the set ID. And then you see, okay, the ID starts at 0. However, at the moment, it stays 0, right? Throughout all the iterations, it stays 0. However, if we add in a mav node and then connect the ID like this, and we add 1 each iteration, now the ID goes up by 1 each iteration, and that's perfect. At the moment it starts at 0, let's actually make this start at 1 to avoid some problems in the future. So now to say that this z-axis is dependent on that ID, we can do an ID node. So if we connect that like this, now you see each number is shifted over the z-axis. To have more control over this again, we want to do a map range node again. But of course, this ID is not going from 0 to 1. This ID is going at the moment from 1 till 4, as you can see. So this max value, we're going to make that 4 for now. However, if we want to make things a bit more procedural, we want to make this from max value dependent on the number of iterations. So if we do an integer node, which we set for now on 4, for example, we can put it like this. And then connect this integer node also with the from max value of the map range node. And now if you make the integer value higher, you will see we're adding in more leaves and it's dependent on it. So now to have more rotation, we can put the to max value higher. So like this, for example. And this way we're already getting kind of like a leaf. However, let's add in more leaves. So if we put the integer value over here on, for example, 60, yeah, that doesn't really look like a flower. And that's because not only do we want that with each iteration the leaf goes up a little bit, we also want that the leaf becomes smaller each iteration. So let's set this scaling value on a value like 0.98, for example, or 0.99. And then we can just change this to max value so that it looks a little bit better. Just go somewhere that it looks as random as possible. So kind of like this. We can always change this later, of course. However, before we continue, I can actually understand that if you're looking at these nodes, that you're thinking, oh my god, what is all of this? I have no idea what I'm looking at. How am I ever going to learn this? I wish there was just some way in which I can learn every single node in geometry nodes in a very easy and chill way. Well, then I have good news for you, because I released the Big Notebook. It's a book that explains every single node in geometry nodes in a very easy and clear way. And it starts from the very basics of geometry nodes and slowly progresses towards more advanced techniques. The book is available on my Gumroad, and if you use the code FLOWER, you will get 25% off of your purchase. And by the way, the book is fully updated to Blender 4.2, so every single node has been added in. So if you want to expand your knowledge in geometry nodes, I recommend getting this book today. And with that being said, let's continue the tutorial. So now we already have this, and you see if we look at the map range node for the blooming part, you see we can already make kind of like a blooming effect like this. However, it's not really that realistic, because as you see, if we move it, you see all the leaves are like blooming at the same time at the same speed, and that's not really what we want. We also want that this blooming vector is dependent on the ID of each thing, so that the leaves that are on the outer circle of the flower are blooming more than the leaves that are on the inside. So what we're going to do is adding in an ID node, which we connect with the toMax value like this. And then you see it goes a little bit crazy because this ID goes from 0 to 60 at the moment. And that value is a bit too high for this. So what we're going to do is another map range node, and this from max value, we also want to make that this integer. So let's connect that like this. And now this toMin value will control the blooming for the smaller leaves, and the toMax value will control the blooming for the bigger leaves. So the toMin should have a blooming that is more like this, as you can see. And then if you make the toMax value lower, you see we're getting more of a blooming effect. And that's really cool. So now you can put it like this. Boom. Yes, that's really nice. Okay, now we have this blooming effect, which is amazing. However, there's one more thing that I want to do to make this look a little bit more realistic. And that thing is that the blooming does not start on the whole leaf immediately, but that the top of the leaf starts blooming a little bit earlier than the bottom part of the leaf. And that we are going to do with a gradient texture. So if we do Ctrl-Shift, click on this gradient texture, and then Ctrl-Shift, click on the group output, then you see this gradient texture now looks like this. However, we don't want to make it aligned on the y-axis. We want to make this aligned on the x-axis so that we can make it move over the leaf. So we want to rotate this. So if we go to the gradient texture, we can do a position node so that we get the original position of this gradient texture. And to rotate this, we can do a vector rotate node. And this vector rotate, let's set this from axis angle to Euler. And then the Z rotation, you see if we change that, we can rotate it 90 degrees over the Z axis. And now to move this gradient texture over the leaf, we can do a vector math node. And then if you add something to the X value of this vector, then you see we're moving the gradient texture over the leaf, which is perfect. And now if we remove the viewer node for now, and then if we connect the vector of the gradient texture with the toMax value, you will see that the blooming part becomes a lot more realistic, which is quite cool, I think. More like this, more like a real flower. Oh, by the way, one thing that I kind of found out by accident is that this position node is using the current position of each leaf. However, I actually found better results if we use the original position of the leaf as this position value. And to replace this position node with the actual original position of these leaves, we want to store that value. If we do a store named attribute node and we name this pos or something like that, we can set this from float to vector because the position is a vector. And then if we connect a position node, now we're storing the original position as an attribute on this object. And also let's connect the store named attribute with the set ID. If we connect the set position node again and we go back into this position node, we can remove it and we can replace it with a named attribute node. And then as the name we do pos, of course, and we connect it like this. It just gives a little bit more of a better result. However, you do see that we have to change some variables. So in the map range node of the ID, we want to change the min value like this. And then we can also change this vector, and that works perfectly fine. The next thing that we need to do will be visible if we close the flower. So as you can see, a lot of the leaves are clipping into each other, and that's because they stay flat. But it would be perfect if they bend a little bit around the y-axis so that they kind of connect into each other like a real flower. So to do this, we want to do another matrix transformation. And as you know from earlier, if we want to do another matrix transformation, we're going to do a multiply matrices so that we can add another transformation on top of this. And this transformation, we are again going to do that from a combined transform node, so connected like this. But this time we want to change the y-axis of the thing. So let's put it like over here or something like that. And let's do another combine XYZ node, connect it like this, and then we have control over the separate Y-axis. To make this step in the tutorial a bit more visible, I'm actually going to connect this transformation with the transform point so that we're only having this. And I'm also going to put the iterations on 1 for now so that we only have 1 leaf. To make this leaf bend like this, we want to rotate it over the Y-axis according to the X-axis. So let's do a position node and then also a separate XYZ node, and let's connect the X-axis with the Y-axis. And then you see that already works. That's perfect. And if you want to make this stronger, we can do a math node, which we set on multiply, and if you multiply it, you can make it stronger like this. However, if we now connect this one over here again and this one over there, then you see that doesn't really look good yet. Maybe if we put it like this, yeah, that's a bit better. But let's see what happens if we put more leaves into it, like 60 again. Okay, that looks fine. Yes, that looks good. Let's see what happens if we put it like this. Yeah, if we put it open, then you see it's still bended like a lot. And what we kind of want is that the more it is open, the less it should bend. And if it closes, it should bend again. So this multiply value should be dependent on the blooming part. And this we're going to do by connecting this map range with the multiply node. Put it like that. Yeah, that's not really good yet. So let's modify it a little bit more by adding in another multiply node in the middle. And then let's make this a smaller value like this, kind of. And now if we put this, you see it is not really working yet. I actually forgot one step, and that step is that we have to remap this X value over here, because this X value is like going on a certain range that we don't really like. So let's do a map range node, and the from min and the from max, we're going to find that in the same way as before with the Y-axis. So let's do an attribute statistic node. We want to find the X-axis, and the geometry value is going to be from this store named attribute right over there. So if we connect now like this and like this, now we can make the bending like -1 to 1, and then it should be that if we move this up, yes, that it looks quite good. It is still a little bit playing around with values, but I think this result is already quite cool. In the introduction video, you also saw that I added in those green leaves that are surrounding the red leaves. Let me show you how that's done. That's actually quite easy. So the thing we're going to do is manipulating what object is added in this repeat zone. So we can say, okay, the first 7 leaves should be the green ones and the other ones should be the original ones. And actually in this startup file that I shared with you, I have this object flat leaf. And if we look, yeah, that's this. And this one we're going to use for those surrounding leaves. So let's go back into geometry nodes. So now to get this flat leaf into our geometry nodes, we want to just drag it in right over there, and then we have it. So now to say that it should either add in this flat leaf or the original leaf, we want to do a switch node. And as the true value, we do the original one, and as the false value, we do the green one. And now if you connect this with the set ID, then you see it's now only adding in the flat leaves because the switch is off. However, you see that this effect is not really working for these flat leaves yet. And the reason for that is because we don't have this position attribute for this object. So let's create that. So if we do Shift D to connect it like this, and Shift D this one too to connect it like that, then you see it works perfectly fine. However, now we want to say that it should only take this flat leaf if the ID is higher or lower than a certain number. So if we do a compare node, which we set on integer, then we want to say, okay, if this ID is less than a certain number, change the type of leaf. So if we take this and we set this on 7, for example, then you will see the 7 leaves that are in the middle of the thing are the original leaves, and the rest is all green. So to make this all a little bit easier, we want to do a math node instead, which we set on subtract, and then we want to say, okay, if the ID is lower than 60 subtract it by 7, then you see it works perfectly fine. And this is especially visible in material preview mode. So if you go over here, then you see that looks pretty cool. However, you see the green leaves are a little bit small. So to fix this, let's do a transform geometry nodes. And as the scaling, let's set that up a little bit like this. Then you see it's a little bit overlapping in the leaves. Well, to fix this very quickly, we can go to the bending part of the nodes. And then in the map range node over here, if you change the tune min value to a lower number, then you see you're fixing that problem and it looks amazing, because if we now open it up, it works perfectly fine. I'm actually quite proud that this effect came out so realistic and so cool. However, we can make this a little bit more realistic. As you can see, the leaves are now in a perfect shape. And in real life, leaves are never in a perfect shape. There's like some noise displacement on it. So let's quickly do that. So let's do a set position node right over here. And let's add in some noise to this. Let's do a noise texture and let's connect the color value with the offset. However, then you see it's a bit too much. So let's lower this with a vector math node, which we set on scale. And let's set this on a lower scaling, kind of like 0.3 or something like that. That's still a bit much, I know, but later we're going to fix this. And you also see that it's kind of shifted diagonally, because this noise texture has a range from 0 to 1 and then it will be shifted. However, we do want to have this noise texture to be from -0.5 to 0.5. So let's do another vector math node, which we set on subtract, and let's subtract 0.5 on each axis. And now what we want to do is make it that this noise becomes stronger over the leaf. So at the top of each leaf, the noise should be stronger than at the bottom, of course. So let's do another scale node. And this vector math node should be dependent on the length of each leaf. So if we do a position node and also a separate XYZ node, we can connect the Y-axis. And then we can also change some variables in the noise texture. For example, making the noise a bit smaller like so. That's better. And at the moment, each leaf gets the same pattern of noise. And if we want to randomize that even more, you can put the noise texture from 3D to 4D. And then as the W value, we set the ID of each leaf so that each leaf has a different set of noise. And let's also set the detail a bit higher. Why not? So let's put it like this. And you know what? Let's also do a subdivision surface node right over here so that we have a little bit more geometry to work with. And at the back of our geometry nodes, we can also do a set shade smooth to make it look smooth. And then also maybe another subdivision surface node so that it's all just a bit more smooth. One final thing that I want to do within geometry nodes with you is animating this thing, because I found quite a nice little trick to make this blooming effect look as realistic as possible. So obviously we want to animate this value of the add node. And I see now that I'm going to turn off the subdivision surface modifiers by pressing M so that it all goes a little bit smoother and it doesn't lag that much. So if we go back to this add node, we can move it. And let's say, okay, it should start like this, for example, kind of, yeah. And then let's press I to insert a keyframe. And then let's go on to frame 30, for example, and let's go make it open. And then let's press I again to make another keyframe. However, you see if we play the animation now, it opens up like this. And that's fine, it's cool, but it's we can make it a little bit more cooler, because at the moment it starts slow, it speeds up and it ends slow. And we can manipulate this. So if we change this field from the spreadsheet to the graph editor, we can click on the add node and also on the object, and then we see the curve for this animation. See, start slow, speeds up and slow. However, a cool thing, if you click on this one and you do right click and we do interpolation mode and we set it on back, then you will see it gets this effect that it goes back. And I think that looks a lot cooler than just making it open like we did before. If you want to change the value of this, like the strength of this going back, you can press N to make this pop-up open up and then click on the first keyframe, and then as the back, you can make that less if you want. And then it's like this. If you make it more, then obviously it will go like crazy like that. Cool too, but I don't think you want that. You might have already seen that I already provided you with the texture of this leaf. And I did that because the texturing part of this is not that special or something like that. However, I do want to have a look at it a little bit to give you an overview of what is happening over there. So if we click on the flower and we split our screen in half and we go into the shader editor, then we see this is the material. It's not that special, it's just a bunch of noise textures like combined with each other and mixed with each other. Over here I'm using this image of a petal that you can find in the link in the description, but you don't really need it because it's already in the starting file. However, I use that to get more realism, and also in order to get this like streaked noise over it, I made use of a noise texture which is driven by the original position attribute that we created over here in geometry nodes. However, there is one thing that I want to add to this texture, which I want to show you. And that is to give these leaves like a darker outer edge to make it look more realistic. And this we are going to do with Vertex Paint. So if I turn off the geometry nodes for now, then we see the original leaf. And for this, let's actually go into solid view mode, and then let's go into edit mode. And in edit mode, we want to hold down Alt and select with Shift also these outer edges. And then with these outer edges selected, we can go into Vertex Paint mode. And then you see we have still selected them. Make sure that your color over here is black, and the attribute on which we want to paint on is now named just attribute, but let's name this like darker or something like that. And since we have selected these vertices, we want to make them darker. So if you go into paint over here and do set vertex colors, now you're getting a darker outer edge, which is perfect. If we go into object mode and then into material preview mode, and now to get that attribute into here, we can do an attribute node right over there. And as the name, we do darker. And this we want to multiply with the original color of our leaf. So we can just take this multiply node, shift D it to over there, and then we connect the darker with that. And then you will see if you put the vector up, the outer edge is becoming darker. I don't recommend putting it all the way to 1 because that's a bit too dark, but maybe a little bit like this is already enough. If you want to have more control over what this attribute looks like, you can add in a color ramp, for example, and then set this from linear to B-spline, and then you can make it a little bit more controlled like this. Of course, on one leaf, it's like, yeah, what's the difference, you know? However, if we turn on our geometry nodes, then you see it's a huge difference. This is before and this is after. Especially if you go from Eevee to cycles and you turn on your GPU, you will see it makes a huge difference. And of course, let's also add in a light for this. Otherwise, it's not really going to work. Okay, somewhat like this. Then you see, yes, that's perfect. So there we have the leaf effect that I really want to show you. However, in the introduction video, you also saw that plant growing effect. And I really want to teach you that too. However, that part is so big that it could be like a tutorial in and of itself. So I decided to split that up. So in the description, I have a link to the video that will teach you how to do that. And with that being said, I really hope I was able to give you more ideas of what you can do with matrix nodes. And if I did, please give this video a thumbs up. Comment down below if you have any questions. And if you don't want to miss out on any future videos, I recommend subscribing. And with that being said, check out the Big Notebook and use the code FLOWER to get 25% off. And I see you in the next one.